What's up everybody and welcome to my channel. I got a pretty cool video for you guys today and it's kind of different from my normal tutorials. I want to show some geometry scripting today. So first of all, let me show you what I've made and how it works, and then I'll mention some different use cases, and after that we're gonna recreate this tool together. So in the viewport here I have a wall, and that's a static mesh from the starter content, but it can be any static mesh to be honest. And let's say I want to put a fan inside of this wall. Normally I would need to export the wall to Blender and maybe export the fan as well, so I need the correct size, and then edit the wall in Blender and export it, re-import it back to Unreal, all that kind of stuff. With Geometry Script we can do everything inside of the editor. So over here I have my fan tool, I can select it, and on the right side I have a bunch of options. So I can select the mesh that I want to modify, which is the wall over here. And immediately you can see something is changing. So over here I can hide or show the mesh to modify. So if I hide the original mesh, this is going to be the end result. So we're going to get a wall with a hole inside it. And I can move the fan around so I can put it wherever I want. And besides that, I also exposed a bunch of variables on this fan, so I can change the scale and everything should increase. Oh, this is the length scale, so the actual fan scale, so I can make it bigger or smaller. And I can adjust everything about this fan. So let's say I want to put it in this wall over here, and this is the correct place. Then I'm going to hit my bake and replace mesh button, and it will create a new static mesh for me. So right now, if I move my fan tool out of the way, this is the end result. So I have a new wall with a hole inside it, and it automatically put the fan in the correct place. So that's how it works. And as I mentioned, it can be any static mesh. So over here, I grabbed a view from the starter content. I have this table and I put a small fan inside the table over here. And over here I did the same thing with stairs, so you can see multiple materials and things like that. It doesn't matter, it will still work. And over here I have one mesh that's combined out of 3 walls, so it does need to be one mesh. This has different materials, and again it will simply recreate the existing material and the existing mesh. So yeah, that's pretty much how it works. Over here I got one last example I want to show you. Even if things are scaled, this will still work. So over here this mesh is actually just a cube, so a 1 by 1 cube, and that's scaled up 12 by 3 by 2. So again I can simply grab my fan tool and tell it to modify this mesh. So let's say I want to put the fan in here at the corner, and I'm going to increase it. So I'm going to make it a little bit bigger over here, so I end up with an actual hole. And I can adjust the length of the fan as well. So right now it doesn't reach the end of the wall, but I can adjust everything about this. So I could add a backside ring and all of that stuff, but that's not really geometry script related. So now if I bake and replace the mesh, it will still work, even though the original mesh was scaled. So right now if I go to the mesh in the starter content, so I need to select this one and browse to it, then you will see this is the mesh that's actually been created. So it's the original mesh with the original size. And the hole is over here at the side. So it automatically rescales the mesh, puts the correct materials on it. It even puts collision on it, and you can make the meshes Nanite enabled as well if you would like. So over here, as you can see, all of the meshes that I created with the fan tool are actually Nanite ready. So let me show you that collision is also working. So if I hit play over here and go into the level, and you will see the fans actually rotate. So over here the wall has collision, the table still has collision, all of this stuff works, and also the holes that I cut into it, so I can actually stand inside of the holes and everything works as you expect it would. So yeah, pretty cool and a pretty powerful tool. So I used it to create a fan, but you can make all kinds of stuff. You can make doors, windows, gutters, pipes going through walls, whatever you can think of, basically. So yeah, that's what we're gonna make today. First of all, I'm gonna show the basics of the actual geometry scripting. And after that, I'm gonna show how I integrated the wall fan. The wall fan is pretty much just a blueprint with some exposed variables that I connected to the geometry script. So that's not really too special. So yeah, let's just dive into it. So I'm gonna cut this up into 2 different episodes, I think. In the first episode, we're gonna set up all of the geometry script and show how everything of that works, baking out a new mesh and things like that. And in the second episode, we're actually gonna make the fan tool complete by adding the fan blueprint and exposing all the variables on the geometry script and things like that. So the first episode is mainly for people that are a little bit more advanced with Unreal and just don't know how the geometry scripting stuff works. And the second one is to recreate the entire fan tool like you saw in the preview. So this is a default third-person project, nothing changed in here. You can choose any kind of project, first person, third person, doesn't really matter. Do make sure you use Unreal Engine 5, so I'm using 5.2, but this should be available in all versions of Unreal Engine 5. You do need to enable the plugin, so let's go to Edit Plugins, and we want to look for the Geometry Script plugin. So I already enabled it. You do need to restart the editor, so enable it, restart, and you should be good to go. On a side note, it's experimental, but it doesn't really matter too much in this case because all of this happens inside of the editor, and once the geometry script is done, you will just end up with a default static mesh like any other. So even if you want to release a project with it, it shouldn't really matter because all of this is editor only. So the geometry script is enabled, and I'm going to go to the blueprints folder, and in here I'm going to create the fan tool. So let's right click and create a new blueprint class. We want to enable all of the classes, and we want to look for the GeneratedDynamicMeshActor. So over here, this is a new class enabled by the plugin, and this is the one we want. So this is for actually manipulating the meshes in the editor, and the dynamic mesh actor is used at runtime. So that's the difference between those, and in our case we want to use the generated dynamic mesh actor. So let's select that one, and let's call this my game dev raw fan tool, for example, and let's open it up first. So there's a few different ways of how you can do this, like with any other stuff. I'm gonna add the cylinder as a component over here, so we can actually see the size of the cylinder and compare it to the fan that we're gonna add later, so that's just a little bit easier. You can already also choose to add the cylinder as a dynamic mesh, whatever you prefer, but in this case we're simply gonna add a static mesh over here, and let's call this our cylinder. And on the right side for the static mesh, I'm gonna assign the shape cylinder from the starter content. So this is the mesh that's going to cut the hole in the walls for us. So we can go to the event graph right now. Over here we have all of the default stuff, and we're not going to use any of it. So let's delete everything, and we're going to right click and look for the event on rebuild generated mesh. So if we type rebuild, at the top here, event on rebuild generated mesh. So this is what we want to use. So this kind of behaves like the construction script. If we change anything inside of this blueprint or even drag the blueprint around in the viewport, this event will fire. And it returns the dynamic mesh that we're working with over here as the target mesh. So if you use the dynamic mesh actor at runtime, you will actually do all of the editing in the construction script. And for the generated dynamic mesh in the editor, you want to use this event. So we're going to start with this event, and the first thing we want to do is make sure that we put this cylinder inside of a dynamic mesh so we can work with it. So let's start by doing that. We're going to drag off here, and we're going to allocate a compute mesh. So this node. What this will do, it will return a new dynamic mesh in its own separate space, kind of. So it returns the same thing as this one, only separate from each other, and you cannot see this one by default. So we can use this to make cuts in other meshes and things like that. And in here, we're going to store our cylinder. So we're going to look for a second node that's called copy mesh from component. So let's right click. Oh, thank you. Copy mesh from component. And let's hook it up over here. So the dynamic mesh is the return value over here. And we want to actually plug in the cylinder from our components. So we can simply hook it up like this. And that should be good to go. So there are some options over here in special use cases that you can set, but we don't really need to worry about them in this case. So defaults should work fine. So we have our cylinder stored. And now we want to make sure that we also have a dynamic version of the mesh we want to edit. So in my preview case, that would be the wall. And we're going to use a variable for that. So we're going to create a new variable and call this our mesh to modify. And we want to turn it into a static mesh actor. So look for static mesh actor over here. So if we place a static mesh in the level, it will actually be a static mesh actor over here. So it's an actor that has one component and that's a static mesh. So that's what we're working with. And everything we're going to do in here is going to work with this mesh to modify. So we want to make sure we actually have a mesh to modify assigned. Otherwise, we're not going to execute any of this. So let's grab our mesh to modify, right click it, and we're going to convert it to a validated get. So this is pretty much an isValid node combined with a get node. If it's not valid, it will return this pin. If it's valid, it will return isValid, obviously. So we're going to connect the isValid pin to make sure we're not executing any of this if we don't have a mesh assigned. And then we're going to grab our mesh to modify again. So this is actually the actor that's placed inside of the level. And from this actor, we want to get the static mesh. So the first thing we need to do is get the component. So we're going to get the static mesh component. The static mesh, that's all the way at the bottom. So over here, static mesh component. And from this component, we need the actual mesh that's assigned to it. So over here, if I look at the cylinder, this is my static mesh component. And the mesh that's assigned to it is the shape cylinder. So this is what we want. And in the case of my example, that would be the wall. So we're going to drag off here again, and we're going to get the static mesh. Again, that's all the way at the bottom. So this is what we need, and we want to store this inside of a dynamic mesh as well. So in this case, we're going to copy a mesh from a static mesh. Copy mesh from static mesh over here. So we can hook this up to the success pin. And then the static mesh asset is the static mesh from the component. So we can plug it in over here. And right now, to show things first, I'm going to put this inside of the generated dynamic mesh. So we're going to grab the target mesh from the event and plug that into the dynamic mesh over here. So we're going to change it up a little bit later, but I want to show how this works. So we're going to start by doing it like this. So now we have the two meshes, the cylinder and the wall, both as a dynamic mesh. Let's promote this to a variable as well. So let's drag off here, promote to variable, and call this our new dynamic mesh, or new mesh dynamic. Let's make it that way. And we also want to promote our cylinder to a variable, by the way. So from this success pin, grab the dynamic mesh, promote to variable, and that's my cylinder dynamic. So hook it back up. Success, go to the next one. And now we need to subtract this cylinder from the wall. So we can do that by applying a mesh boolean. So look for apply mesh boolean. Hook it up over here. So the target mesh is our new dynamic mesh. So let's plug that in over here. The tool mesh is our cylinder, so our cylinder dynamic. Plug it in over here as well. For the operation, we're going to set it to subtract, so it will subtract the cylinder from the wall. And then we need to enter the transforms as well. So for the cylinder, we can simply grab it over here, the local to world transform. That's our tool transform. And for the target transform over here, we want to get the world transform from the static mesh component. So let's drag off the static mesh component and look for get world transform. And simply plug that in over here. So this will actually create the mesh with the hole in it. So let's have a little look and see how this looks inside of the viewport. So let's move this to the side. We're going to grab a viewport. And in here we want to put a wall or something where we can put our new tool in. So let's go to starter content and I'm just going to grab a wall in here. Doesn't really matter. Let's grab our fan tool as well. And let's make sure that it actually intersects with the wall. There we go. So now if we have the fan tool selected on the right side, we can look for our mesh to modify if we actually make it instance editable. So we want to go inside of the fan tool and select our mesh to modify over here, enter instance editable, and if you do that, then it will pop up inside of the details panel over here, and you can actually assign it. So over here, default mesh to modify, we can grab the little eyedropper and simply click on the wall. And you will see right now it will generate the dynamic mesh with the hole in it. So if I move this cylinder around, you can see the hole actually moves to the correct position and it updates live as it should. So that's not too bad. But it actually spawns it at the origin of our generated mesh actor. Now, in a way that's good, but in another way that's also not really what we want. So if we want to use this as a preview, you actually want to spawn it on top of the existing wall. But if you bake it out, the origin will be at the origin of the generated mesh actor. So what we kind of want to do is bake it out the way it is right now, but if we want to have a preview, we want to move it. So what we're going to do, we're going to move this visible mesh to a separate section, so it only uses it for a preview, and then we're going to use allocated compute meshes to make this mesh over here that you see right now, and that's the mesh that we're going to bake out later. So that's how it's going to work. So let's remove the viewport again and go back to the fan tool. So like I mentioned, we want to put this wall mesh inside of a allocated compute mesh. So we're going to disconnect the toDynamic mesh over here from copy mesh to static mesh. And we're going to move it to the side a little bit. And before this, we're going to allocate a compute mesh again. So plug this in and plug the return value into the dynamic mesh. So if you do this, you want to make sure that this one is stored as a variable, otherwise it will simply override it and you cannot access the cylinder anymore. So that's why we're storing this as a variable, and then we're allocating another one and we're storing that wall inside of that one. So over here everything should still be fine, so we're still using the cylinder to cut a hole inside of our new mesh dynamic. That's good. Now we also want to add our preview mesh to it. So we're going to grab this copy mesh from static mesh again, and let's paste it down here. So we can simply hook up the mesh boolean over here. And in this case, we are going to use the mesh from the event. So we're going to grab the target mesh over here and plug it into the dynamic mesh. So this is the mesh that we can actually see in the editor. And to make sure that this is actually aligned properly, we're going to transform this mesh. So drag off the dynamic mesh and look for transform mesh. So we can hook it up to the success pin, and we actually want to make a relative transform from the static mesh component to this actor. So we can drag off the static mesh component and get the world transform. So from this world transform, we can make a relative transform. So this goes into the A pin, and then we're going to right click in an empty spot and get the world transform from this actor. So get actor world transform. Oh, sorry, not that one. So right click, get world transform. Let me see what the actual. Oh, maybe I shouldn't put world in here. Okay, get actor transform. That's the one you want. So simply this node, and we can plug it into the relative 2 pin. So this is going to be the new transform for the wall mesh. And then again, we want to apply the boolean. So there's actually a hole inside of the mesh. So let's grab the mesh boolean, paste it over here, plug it in. So this time the target mesh is simply the return value from the transform mesh. So we don't need to store this as a variable in this case. And the tool mesh again is our cylinder dynamic. So we can simply plug it in over here. Make sure we have it set to subtract, and that should be good to go. And we don't need to mess with the transforms in here. Those should be fine. So right now we have a separate dynamic mesh over here with a hole in it to use for our preview, and we have the allocated meshes over here we cannot see, but they still are there, and those are the ones we're going to bake out later. So I found this works a little bit easier this way. You could simply use the target mesh over here to do both of them. So right before you bake it out, you want to change the transform to the original transform again, but that gets a little bit messy, and working with relative transforms can be a little bit annoying sometimes, at least for me. I'm not too used to them yet. So I found this to be a pretty decent solution. So right now, if we compile and save, everything should look a little bit different. So let's go back to our viewport. And as you can see, that should work. So right now we have the example mesh overlapping the original mesh. So that's cool. And the actual allocated mesh is still over here where the mesh was previously in our earlier attempt. You just cannot see it. So this is good, that's what we want. Let's close this again, and let's go to our fan tool. The first thing I want to do in the viewport is make sure that this cylinder is not visible. So I'm going to go down over here to rendering and simply disable the visibility. Now, because we don't have any other components in here, we cannot select it anymore in the viewport. So I'm simply going to add a simple sphere in here and move it a little bit down, and also shrink it a little bit, so we can actually still select it and see it in the viewport, but this sphere doesn't do anything. So that's just to select it. And now we're going to create a function, and that function is going to hide or show the mesh that we want to transform, so the mesh to modify. So over here, functions, let's create a new one and call this hide show mesh to modify. So this function on the right side over here, we have a little tick box, call in editor. If we enable this tick box, we can actually call it from the details panel over here, but we do need to make sure this function does not have any inputs. So you cannot have inputs inside of a call in editor event. If you do so, it will not show up in the details panel. So make sure no inputs in here. And what we're going to do in here is simply grab our mesh to modify again and make sure we actually have it assigned. So we're going to convert it to a validated get, plug it in over here, and we're going to continue from the isValid pin. Now we want to grab our static mesh component again. And from the static mesh component, we want to get the visibility. So let's drag off here and do isVisible. And we also want to set it. So drag off the static mesh component again and set visibility. So if we plug this into the isValid pin and simply flip this around with a not boolean, so look for not boolean, then it will switch from visible to not visible. So we have this set up. Let's compile it and save it and go back to our example. Grab our viewport in here. And right now, with the fan tool selected, if we go to the details panel over here, so we have our new function, hide show mesh to modify, and if I click this button, you will see the original mesh disappears and we are left with our preview mesh. And if I click it again, the original mesh returns. So that's how you can make functions callable in an editor as well, as long as you make sure there's no input. So yeah, that's pretty cool. That's all good to go. Now all we need to do is bake out this mesh to a new static mesh. So that's what we're going to do next. So let's open up our fan tool again. And we're going to create a second function in here. And I'm going to call this bake and replace mesh. So we want to make this call in editor again, so it shows up inside of our details panel. And we need two variables in here, which are strings. So let's create a new variable, and the first one is the new asset base name. And make sure it's a string. And we're gonna make a second one, and that's our override folder path. So for both of these, we want to make sure they are instance editable. So make sure you enable them for both. And the first thing we're going to do in here is grab a branch and make sure that we actually entered a new asset base name. So let's drag off the asset base name and do a not equal to. So it doesn't really matter which one you choose. We're not going to put any text in here anyway. So simply hook it up and that should be good to go. Then we're going to grab a second branch, plug it into the true pin, and we're going to check our override folder path. So what this will do, if you want to save the new mesh in a specific folder, you can type it inside of this folder path. If you leave it empty, it will simply store the new mesh inside of the same folder as our mesh to modify. So we're going to drag off our override folder path and we're going to compare it. So again, it doesn't matter which one you choose because we're going to leave it empty anyway. Plug it in over here. So if it's empty, we want to use our existing folder path, and otherwise we're going to use this one. So we're going to need a local variable. Drag off the string, promote to local variable, local override folder path or new folder path. Let's make it that, new folder path. So if this is false, we want to override folder path, put that in here. So let's just hook it up like this so it looks a little bit cleaner. And if this is true, so if it's empty, then we want to use the folder path from our mesh to modify. So let's grab the mesh to modify. And from that, we need to get our static mesh component. And from the static mesh component, we need to get the actual static mesh again. So the mesh to modify is an actor that doesn't have a path inside of our content browser, and the same goes for the component. So we need the actual static mesh, and that has a folder path. So we can drag off the static mesh and get an object path string. So this one. But this will also return the file name with it, and we only need the path. So if we drag off here, we can do get path. And this will actually remove the file name from the path. So hook it up like this and then plug this into the new folder path. So that's good to go. Then we can grab a node called create unique new asset path name. So create unique new asset path name. Look for this one. Hook up both of the execution pins. So the folder path is our local variable, the new folder path. And our asset base name is our new asset base name. And that should work. So for the options, it's going to put random digits behind our base name, so you can specify how many random digits you want. It's not really that exciting. So this should work, and this will return a unique name. And now we need to actually save our new asset. So we're going to right click again and create a new static mesh asset from mesh. So create new static mesh asset from mesh. Hook it up to the success pin. So we want to create it from our new dynamic mesh. So we're going to plug that in over here. And we actually need to specify our asset path and name. So we can simply grab it over here. That's the path with the new file name attached to it. And this will return a new static mesh asset. So we're nearly good to go. There's one thing we need to do. We need to make sure that we assign the correct materials to this new dynamic mesh. So as you saw in the editor, by default, it will just have the world grid material assigned. So we need to copy over the correct materials from our existing asset. So first of all, let's promote this to a local variable. And that's our local new static mesh asset. New static mesh asset. And hook it up to the completed pin or success pin. And now we want to get the materials from our mesh to modify. So the original mesh in the level. So let's drag that in here. Now you could get the materials from here, but if you change them in the details panel, so if you override the material from the static mesh over here, this will not be taken into account over here. So what you want to do is drag off the mesh to modify and get the static mesh component again. Static mesh component. And if we get the materials from here, it will actually take into account if you overridden them in the details panel. So from the component, we can drag off and get the materials, the plural one, so with an S behind it, so it returns an array. And we also want to get the material slot names, so get material slot names, and that will return an array as well. So we need to make sure we put the correct material in the correct slot. So we're going to grab a for each loop, and we're going to loop through all of the materials. And then we want to drag off our mesh component again, and we want to get a material index. So get material index. And, oh, freaking really, my mouse freaked. What the actual, okay. There could be a button stuck or something, I don't know what happened there. So get material index, and in here we need to plug in a slot name, and that will return the correct index for us to put the material in. So these two arrays are actually matched up. So the material in index 1 corresponds with the slot name in index 1, for example. So what we can do over here is drag off the slot names and get a copy. Plug in the index from the for each loop, and then plug in the slot name over here. And after we did that, we can assign the material to our new static mesh asset. So let's drag in our new static mesh asset, set a material. And for the index, we're going to use this return value. And for the actual material, we're going to use the array element, hook this up to the loop body. So this will make sure the correct materials will be assigned to the correct slots in the correct index. So after we did that, we want to save our new asset. So let's drag off the completed pin, and we're going to save a loaded asset. And the asset we want to save is our new static mesh asset. So let's plug that one in. And from this point on, we actually have a new asset inside of the content browser, and that's our wall with the hole inside of it. So what we can do right now is actually delete our mesh to modify in the level and spawn our new mesh. So that's what we're going to do over here. So we're going to spawn an actor from class. And we want to spawn a static mesh actor. So why does this should give a transform? Why spawn actor Oh, this is a level utility, so you want a game one? So this is the one you want. I didn't even know there was a second one until right now. Obviously there is. So spawn actor from class, and over here you want to spawn a static mesh actor. So the spawn transform, we can simply grab it from our mesh to modify. Let's drag it in here and get the actor transform. Hook it up over here. So let's make sure the spawning actually succeeded. So we're going to drag over here, is valid, and plug it in. If this is valid, we need to actually assign our new static mesh. So we're going to drag off and get the static mesh component from this actor. And from the static mesh component, we can set the static mesh. And our new static mesh is our new static mesh asset over here. So this spawns the new mesh that we created. Now let's make sure this succeeded as well. And if it succeeded, we can grab our mesh to modify and simply destroy it. Destroy actor, plug it into the true pin. And now we should be good to go. So this should replace our existing mesh with the new one. There is one pretty important thing you want to do over here to finish things up, and that's release all computed meshes. I'm sorry. So over here in the event graph, we used these allocate compute mesh nodes. So every time this event fires, everything will reset, and those will also be cleared. But if we simply hit this bake and replace button, we need to do it manually. So make sure you release all of the compute meshes and make sure you hook up the false pins as well. So if anything goes wrong, those will still be released. Okay, so now we should be good to go. So if we go back into the level, this should actually work. So right now in the details panel, we should have a new button, bake and replace mesh. So we do need to make sure we actually enter a new asset base name. So let's call this wall fan. And then we can bake and replace mesh. And if we move our fan tool to the side, you will see over here our new static mesh is created. And if we actually browse to it, it's also inside of the content browser over here. So we have a new static mesh and everything is set up and good to go. I think I got everything covered except for one little small thing. So if we go back inside of our blueprint, over here for the create new static mesh asset from mesh, we actually have some interesting options. So if we drag off here and make a struct, so over here we can actually enable Nanite, for example. So hit this little tick box and drag off the Nanite settings and also enable it over here. So this will enable Nanite if you enable both of these. And you can also set the collision over here. So if you use complex as simple, it will auto generate collision, or not really generate, but it will use the complex collision. There's also options for you to manually create new collision if you like to, but this should work pretty nicely in our case. So compile and save, and now we are actually done with the geometry scripting. So that wasn't really too bad. Now this isn't really too complicated of a use case, but still it works pretty good. And so again, if we move our fan tool over here and make sure that we assign the correct mesh. So we have the hide and show button, that still works. And we can simply leave the name because it will put random numbers behind it. So bake and replace mesh. And right now we should have a mesh with Nanite enabled and collision. So if we go to Nanite visualization, you will see Nanite is enabled over here. And if we actually play in editor, this will also have collision. So yeah, that's work. Pretty cool, pretty powerful tool, and as I mentioned in the intro, there's a lot you can do with this. So this is a really simple example, but you can make this as complicated as you want. So yeah, hope you enjoyed this video. If you did, please consider leaving a like, and if you're interested in the rest of the pen tool, I'll be doing a follow-up video for that one as well. So thanks for watching, everybody. Talk to you later. Bye bye.